Now I am going to discuss mixture requirement in SI engine for various load condition. See, as we know, air fuel ratio is three types. One is stoichiometric ratio, that is 15:1, and less than that means air amount is less, fuel amount is more, that is called rich fuel. And 15, after 15, 16, 17, 18 ratio, that is called weak, because their air ratio is more, fuel ratio is less, so that is called lean or weak ratio, air fuel ratio. Now that what are the conditions? That is very, very important question for MDU examination. 99% chances that you are going to get this question. Explain the mixture requirement in SI engine for various load condition. Okay, that is very, very important, and that can be explained with the help of diagram only. Okay, so without diagram we cannot explain. See now. Okay, now this is percentage of, no, it is better, air fuel ratio. Okay, this is percentage of throttle opening. How much opening means? When we need more fuel, then throttle valve should open. Okay, so let us like this: 10, 20, 30, 40, 50, 60, 70, 80, 90 and 100%. Okay, percent of the throttle. Air fuel ratio, let us talk 10, 12, 14, 15, 16, 18 and 20. As I told you, less than 10 or more than 20 cannot burn efficiently, so that ratio should not be used. So 15 we know that is your stoichiometric ratio. This is called chemically correct ratio. Okay, this is called chemically correct ratio. It is also called stoichiometric ratio. Okay, so that is 15:1. Now see here, we have to start like this: 20, that is also, once again, it is going to near about 12 only. Okay, this is also air fuel ratio. See, this is portion A, this is B, this is C and D portion. Now AB portion is called starting, idling and low load condition. B to C, part running, load condition, that is also called cruising. Okay. Number 3, C to D is called acceleration. Okay, this, apart from these 3 portions, we have to discuss another 2 points also. That point let us consider here itself. That is point number 1, 2, 3, 4 is for maximum power. Number 5, maximum efficiency, or it is called minimum fuel consumption or fuel economy, fuel consumption, or it is called fuel economy. So if we discuss these 5 points, then only we can complete the question. Mixture requirement in SI engine, that means air fuel ratio, see here, that is air fuel ratio, okay. Air fuel ratio, first condition is starting engine. When we want to start, then that time due to cold we have to supply the rich fuel, because air ratio, see here, 12 kg only, and air fuel will be more there. And up to point B, that is starting, idling, that means no load condition or low load condition, we need, this portion is also called rich fuel. To start the engine, we need rich fuel. Rich fuel is less than a stoichiometric ratio, that is 15:1, this is 15:1. Less than that, that means air ratio is 12, suppose, so that we can call it as rich fuel, okay. So rich fuel will be from point A to B for starting, idling and low load condition. Number 2 to 3, that is called normal running, this is called cruising also. This is very, very important part, because this is up to 20% of the total load, and this is for 20%, and this is for, see here, 20 to 80 is almost 60%, and this is cruising. And when you want to accelerate, once again you have to supply the rich fuel, okay. So rich fuel means once again you have to go above 15, okay. So that means above means that is air ratio should be less than 15 kg, so we have to go for once again 12, 13, something like that, okay. So that way we can go for these 3 conditions. Starting, idling, low load condition is A to B, where rich fuel supply should be there. Then it is not advised to run the engine all the time like this. Normal running should be there, for that is near about 60%. So that is near to, even stoichiometric ratio gives the best output, okay. Even below that one also, maximum above this stoichiometric ratio, that is rich fuel, it is not advisable to use that ratio, okay. So better to go near to a stoichiometric ratio, chemically correct ratio. So this is cruising is almost 60%, and C to D is acceleration, where we want to increase the speed, then we have to supply the more fuel. So in that case air ratio will be less. Here, see here, air is almost 10 kg or 12 kg, and fuel ratio will be more. Now apart from these 3 portions we have discussed, 4th portion is maximum power. See, maximum power, and point number 4 and 5 can be explained by the help of this diagram, okay. See now, percentage, suppose here I am writing 40, 50, 60, 70, 80, 90, and it is 100, okay. That is maximum power, and here that is air fuel ratio. So let us take it as, once again here, 10, 12, 14, this is 15, then 16, then 18, okay. Below more than that we cannot go, because this is our stoichiometric ratio 15, that is chemically correct, okay. See here, this is a stoichiometric ratio. Now when we want maximum power, so maximum power will be, see here, like that, maximum power, then we have to, this is a rich fuel, am I right, and this is lean fuel ratio, this is rich fuel. So if we want to increase the power, so it will have like this, so it is maximum power, it will give you maximum power. If we talk about maximum efficiency, that means fuel should burn, it should have minimum fuel consumption or fuel economy, that will be like this. This is 100 maximum power. Okay. Now this one going okay. So we can use this one. This is for maximum economy, that fuel should use, and this crosses here like this. That means what this figure says, see there are 2 points, maximum power. Power means you want to give more power, that means air fuel ratio should be reach. So reach, that means near about 13. See this ratio is 13 and that is for maximum power. Maximum power, if you want to have the maximum power or you want to speed up your engine, that means there you have to give the air fuel ratio reach, that is 13. So it gives you the maximum power. But it is not advised to run the engine at this condition because it consumes lot of fuel and it is not good also for the engine. Then what is it? Another option is efficient, maximum efficiency, that means minimum fuel consumption or fuel economy should be there. So see this is best condition, but this one will be 17 actually. This will, if you have air fuel ratio 17:1, this is maximum power 15:1, so 17:1 will give you maximum fuel economy. That means better condition, and mixing of the air and fuel at the ratio 17:1 will use minimum fuel and gives the maximum output. So it is always advised to run the engine at this condition because this is very, very important. Economy, that means minimum specific fuel consumption or economy condition, maximum efficiency. Maximum power is not advised because this is using the fuel at maximum condition. So whenever mixture requirement in SI engine for the various load condition question comes in your exam, you have to explain all the 5 portions by the help of this diagram and this diagram. So let us repeat the same, how it works. Mixture requirement. So mixture requirement, see, that is started from 10, 15 is your stoichiometric ratio, chemically correct. That is less than this ratio is called rich fuel. This is called, see, rich fuel, and more than this 15, that means 16 air kg. 16 kg air, fuel ratio is air is more, fuel is less actually. So that is called lean fuel. Okay, so that is lean fuel. So air is here, this is called rich fuel and this is called lean fuel. And if we talk about this diagram, there are 5 portions we have to study: A to B, B to C, C to D. This is called starting, idling and almost low load condition. This is normal running, that is cruising, that is near about 20% to 60% of the total running should run as this portion, and 20% this and 20% this for acceleration. So starting, idling and low load condition, that should be reached. And part running, it is called cruising, that is near about 60%, and when we want to increase the speed, accelerate the speed, definitely we have to supply the rich fuel. So air will be just 12 or something and fuel 1 kg, so it is called amount of air is less, so it is called fuel is more, so it is called rich fuel. Here suppose 16 kg of air and fuel is 1 kg only, so it is called lean or weak fuel. After discussing these three things, we have to add up 2 things: maximum power, when it will give you the maximum power, and when it will give you the maximum efficiency. See, if you take the diagram, this diagram, with this diagram we can explain both this portion 4 and 5. See, this is stoichiometric ratio 15, okay, 15:1. Before that one it is rich and after this it is lean. So when we want to speed up or if we want to give the maximum power, then our fuel ratio should be rich. That means air ratio should be less and fuel ratio should be more here. So it is called rich fuel. That is near about, that is 15, not 15, maximum power gives us 13 is to 1. 15 is our stoichiometric ratio, okay. So 13 is to 1 gives the maximum power, because here it is fuel is rich and it is it gives the maximum power, but it is not advised to use the engine for this condition because it consumes more fuel. So it is not advised. Then another option is minimum fuel consumption or economy. For that, what we have to do go? That is this one, maximum economy. Okay. So at that 17, near about 17 is to 1. That means air amount is more, fuel ratio is less. So it is called lean or weak fuel ratio. So that gives at this 17 is to 1, that is maximum economy or maximum efficiency or minimum fuel consumption. So if we talk about all these 5 requirements, various load conditions, see various load 1, 2, 3, when you want to start, when you want to load condition, part running, acceleration, maximum power, maximum efficiency. So there are 5 parts of this question. So you have to explain all these 5 parts by the help of this diagram, both the diagram. This diagram will consider this 3 points and this diagram for these 2 points. Okay. So you have to consider this figure, both figure. Without the help of this figure, we cannot explain what is the mixture requirement in SI engine for various load condition. Okay. Rest of the thing I will discuss in next class. Thank you.